introduce myself quickly first. I'm relatively new to software development. I probably started learning HTML5, CSS and JavaScript about 5 years ago when I was a primary school teacher actually, and then over the last 5 years I've kind of slowly progressed, did a bit of data analysis, built some websites with WordPress, and then kind of got into front-end dev stuff. I also did quite a bit of C# as well with things like ASP.NET. So I've kind of gone from mainly doing C# ASP.NET to this year just working in React with JavaScript and TypeScript as well. I came across Firebase probably about 4 months ago, and I was just Googling for places where I could host a static website. And there was things like Netlify, which looks pretty good, which you could just host a static site for free. And also Firebase came up as well. I know Firebase has been around for a while and is owned by Google, so it's got kind of good support, good infrastructure in place, I would assume. I've called it all you need for serverless web apps, Firebase and React, which is kind of based off an article I read, which I think was Firebase and React all you need. And I think I would agree with that in the way where React, lots of people use, is a good front-end framework, and Firebase is a very quick and easy way to store data instead of like maybe a back-end database, because you can just, it's all uses front-end code. So I think those two work quite well together. So I'll kind of go over a little bit about what Firebase does. Out of curiosity, how many people have used Firebase? Okay, so quite a few. Relatively familiar with it. These are some of the things Firebase can do. So static hosting is the one that I came across first. It also has its own authentication. It's got a real-time database, which was its database for a long time. Real-time meaning that it could, if someone else used an app you wrote, for example, and they updated it, and you were on the app as well, maybe online, then you would see those updates instantly, a bit like when two people are using a Google Doc or something like that. There's also Firestore, which is basically the real-time database 2.0. There were quite a few gripes with the real-time database, which I'll share an article a bit later, which gives it quite a scathing review, and I think they learned a lot from that. So they've built Firestore now to kind of address a lot of those problems. It also has cloud storage, so you can use it to save things like images, media, files. And also, the next two components are quite new. I think they're still in beta. Cloud functions and the machine learning kit. So they're starting to kind of integrate, I think, Firebase with Google Cloud. So you can use things like cloud functions from Google Cloud, and I've never used them before, so I'm not that familiar with them, but I think they can kind of pair the two quite nicely. And machine learning is very cool, so they've integrated that as well. Again, I'm not familiar with that myself. These are some reasons of why I would recommend to use Firebase and why I use it personally. There's no need to write any backend code to implement a database, authentication or storage. So where I came from doing a lot of C# with ASP.NET, had to write lots of server-side code, set up a SQL database, and it was quite a bit of boilerplate to write and a bit of head work just to get the back end set up completely. So with Firebase, it's a lot easier. There's a lot less code, which I'll share a bit later, how you can what the code looks like. So it's a lot easier to just have access to a database without having to write a whole bunch of back-end server-side code. I quite like the real-time nature of the real-time database and the Firestore, because it allows for automatic updates for the user if data has changed. So it avoids you needing to write things like WebSockets and doing some other kind of complex back-end code, as well as the real-time updates are just built in. You don't need to manage infrastructure or servers. Where you've got backend code, for example, and you need to kind of manage that in the cloud or wherever you've got it hosted, you don't need to worry about that. So you're not going to kind of run into any problems involved with the infrastructure, which I quite like specifically from I've mainly used Firebase for just my own projects, where I'm just working on it part-time at home, so I want to be quite quick and agile and develop stuff quickly without having to worry about pairing the back end with the front end. And there's also access to a bunch of integrated tools such as analytics, crash reporting, performance monitoring, and testing tools. Again, I'm not that familiar with those. I haven't really used those elements of it, but I would imagine because they're all part of Firebase that they're going to integrate quite well. And you can also build progressive web apps that work offline. I think Firebase originally started as mainly a backend for mobile developers, and so they had the functionality with the Realtime Database to be able to store information and data from your app even when the user wasn't online or if the connection was a bit dodgy. I know with the new Firestore, you're now able to have that offline access to the database while you're offline, when you're not connected. So Google are big supporters of building progressive web apps, and so that's why I think they've kind of introduced this into Firestore, just to push that progressive web app angle. So here's a little bit of code to do with authentication. I have a feeling it works with Auth-O as well, as there's quite a bit of documentation around that, but I haven't used that aspect of it. But because lots of the authentication is built into Firebase, it makes it a lot easier when you're accessing the Firestore to be able to do things like authenticate your user and make sure the user's getting the correct data. This specific example was where I used, this is inside React with Redux, and I used Redux Thunk, which basically, instead of, I'll stand up here, yep. Instead of dispatching your action straight away, as the reducer doesn't really handle async functionality. So in this case, you basically send the dispatch function, and then you call whatever you need to do. In this case, I have just used Firebase.auth, and I've signed in with a pop-up provider. In this case, I've used the Google Auth provider. And then it makes sure you're signed in, and then once you've made your async call, you can then dispatch to the reducer to do whatever you need to do, update the state, for example. So this is an example of how I've used it with Redux and Redux Thunk, but also how the authentication works. So that's literally all it is to sign someone in. And on the right there, I've just got some of the services you can connect with at the moment with Redux. The main ones probably people use are Google, Facebook, and Twitter. I know using things like Google is really, really easy. Like the Google Auth provider, that's all it is. With Facebook, I know you need to have Facebook dev account and set up API keys and things like that. I've read that the email password is a bit more complex, but I haven't used that one specifically yet. So first element is static site hosting. So it's free. I think that's probably one of the biggest perks. It's quite fast because, as I've taken a quote, cached on SSDs at CDN edge servers around the world. My very limited understanding of CDN edge servers is that, well, that sounds pretty good. There's free SSL certificates for custom domains. When I've done stuff with GoDaddy and other domains, and you've got to pay £100 or whatever it is for an SSL certificate, I didn't actually realise you could get them for free, so that was a good perk as well. You can see deployment history and roll back to a previous version from the Firebase console. and it uses Google infrastructure, which I would trust would be quite reliable and fast. And you can kind of keep everything in the same platform. So rather than having an app hosted here, use a database here, and use authentication over there, you can use everything on Firebase and access it all from the Firebase console. And the real-time database was the original Firebase database. It's a NoSQL database. All data is stored in a single JSON document, which obviously can get very messy quite fast. And a lot of the kind of complaints about the real-time database were around this storing the data in a JSON object. For example, if you wanted to query one segment of data, you also had to get all the children belonging to that data as well, which was not necessarily going to be efficient. It uses real-time snapshot subscribers to automatically update the client when a change is detected in the database. I don't have an example from the real-time database, but the Firestore, I'll have an example later of what the snapshot looks like. It's good for storage of simple data models, but it had trouble scaling when reaching 100,000 concurrent users. Obviously, that's quite a big deal. You'd have to have a very big and popular application to actually be reaching 100,000 concurrent users. But from what I gather, when they reached 100,000 users, you had to do things like sharding the database and using multiple databases, which I've read was a world of pain for the people who reached that. Complex hierarchical data is harder to organize at scale, so this is just another negative of the real-time database. There's no offline support for web, and you've got some limited sorting and filtering functionality. So coming over to the Firestore, they learnt a lot from the real-time database. It's currently in beta. If you go to set up a new database using Firebase, it will pretty much have on-screen Firestore, and you've kind of got to scroll down a little bit to choose the real-time database. So they're really telling users to use Firestore because it's the new and improved. It's going to be a lot better than real-time database, but basically warn you it's currently in beta, so just to not complain too much if it breaks. It's a document-based structure which allows for quicker querying of large data sets. I'm quite new to NoSQL. Using Firestore was the first time I've used it. I'm mainly used to SQL Server and that kind of database structure. So a document-based structure might mean more to you than it did to me when I first read it, but I've got an example on the next couple of slides to explain what a document-based structure is. And complex hierarchical data is easier to organize at scale using sub-collections within documents. So the way they use it, if you query a parent, you don't need to get all its children as well. So it's a lot more efficient in that regards. Okay, so here's a picture I found of a description of a document-based database. And out of curiosity, who's familiar with NoSQL and a document-based database? Okay, quite a few people as well. So, and this is how the Firestore database works, where you have a collection. So that whole thing is a collection. Various collection. Actually, that I think is a document, because within a document you can have various collections. Hang on, let me just think about that. One document, various collections. Okay, each one of these is a document, sorry. And then, so this document, a document will be like just a simple JSON object, for example. You might have first name, last name, ID, and that might be your user, but then the user can have multiple collections as well. And then a user can have multiple collections, and each collection can have multiple documents. And there might be a better example on the next page. Okay, so there's an example there. So at the top right, you've got 3 users, and one user, Joe, has a collection of workouts, and the workouts as each one is a separate document. And I will flick over to what it actually looks like in the Firebase database. This did start as just a demo that I did when I was learning how to use Firestore, but I've actually manually changed it just so it kind of explains it a little bit better. But basically here you've got so users. So here you've got a collection of users, and you've got, at the moment I've only got 2 documents, which are 2 different users, both happen to be me. And so this one document has details about this user, and also has 2 collections. So I've got a collection of items, each one of these is a document, and also a collection of lists there. I find this way of looking at the database quite useful, especially when developing stuff, because you can also test the real-time nature of it by kind of manually changing something here. Update, and then you can just see it change in your app. So this is how Firestore does a write. As long as you've got your Firestore DB, actually my present mode there. And then you can grab your collection, in this case collection of users, grab the document, and the document is the document ID. In this case I've just created the document ID to be the user ID, and then I've got a collection of items over there, .add, and then you literally just add straight in a JavaScript object. In this case I've got time added and an item. And then you've got your .then, so basically it'll do the add, and then you've got your reference to the document so you can do whatever else you want with it. In this case I've just logged it to the console. Okay, and this is what a subscriber looks like. So the first one was how you save to the database, and this is the case of creating the subscriber to make sure that if it changes in the database, that it automatically updates on your screen. With Real-Time Database, there was different kind of snapshot handlers. You could do on change, on add, and on delete, I think, something like that. Firestore have made it a little bit simpler. It's simply on snapshot. So you just call on snapshot, and then you send a callback function. In this case, I have, what have I done? Class list collection. Okay, so in this case, I've got a collection of class lists, and every time the collection of class lists updates, I've just got all the lists here. So it'll return, basically, if one thing in your collection, if one document in the collection changes, in this case, it'll return every single document. So I've just gone through each different document, created a class list out of it, and then dispatched it to the Redux store. You can, so it's I kind of, I suppose my thoughts on the way I've used this in Redux is every time one document updates, I've cleared the Redux store of all the documents and I've repopulated it. At the moment, doing that performance-wise is not kind of major effect, but what you can do is with your snapshot, you can, for example, only reflect the documents that do have changes and things like that. So there is a little bit of flexibility around what you decide to update. These are just some examples of some queries. So I think with Firestore, you still want to use it for relatively simple applications. I think anything that's going to be kind of more complex or that's going to have different types of users, different admins, then Firestore is probably not the best Firebase database to use. But Firestore does have a few better querying capabilities as a real-time database. So you can just do simple things like, in this case, I've got cities references where the state equals CA or where population is less than 100,000. This was a bit odd to me when I first looked at it, because you're basically calling a method and then each of the arguments is just the string. So you've got these two equal signs in double quotes, but that's how they've done it. And you can also do compound queries, so where you do two more queries together, and there's ordering as well. I know in Firestore there's lots of indexing you can use as well. So if you do similar kinds of ordering and queries, you can set up the indexing and it'll make it faster. Because everything is front-end code, everyone basically has access to your details on how to access your Firestore. The only thing they don't have access to is the Firestore rules. So the rules are what you write, upload to Firestore itself to specify what people are allowed to read and what people are allowed to write. So basically you only want users to be able to write to their own files using their authorization. And they can get quite complex about what can be read and what can be written, but you can also have the mode where anything's accessible to everyone, which is easy when you're first starting to develop stuff. I've shown you this. That was the Firestore structure for a list app. And this is one kind of problem I ran into, or I suppose a consideration I needed when I was building one particular app with React and Redux. And this is how I've kind of handled the idea of state. So with Firestore, because it's real-time as well, you effectively have two states. So you've got the Firestore state and the Redux state. And keeping them in sync is obviously important. So the way I've done it is basically, you've got the component, and inside the component I've got a save to Firestore function, which comes from a file which I've called the Firestore repository, and that will save it directly to Firestore. So then Firestore, I've got a separate file called snapshot handlers, which takes the snapshot from Firestore, and that's what I use to update Redux. So effectively, if someone, for example, clicks a checkbox, click the checkbox, there at the moment there's like a half second delay as the update check to get saved to Firestore, and then it waits for the snapshot to actually update the checkbox. And I'm tossing up whether I like that or not, because I want it to be a bit quicker. But this is a nice clean way of doing it. Okay, so I've set up an application, and I'm going to write this on here very quickly. So you can pull out your phones and type in this email URL TUHV. Okay, I hope you can read that okay. I'll give you a second to type that one in. So this is just an application I wrote to basically demo Firebase and to kind of show the real-time nature of it, a bit of an example of what it can be used for. So if you, let's see, all right. I'll switch over to it now, so if you need to keep writing the URL, you can just write it from up there. I think this might work okay. Okay, so I've tried to match a color with what color you've got in your phone, so you can kind of try and find it easily what you're doing. But you can kind of test out, you can see that when you type something in, there is a slight delay, but I think the delay is reasonably usable. And I think I tested this with about 5 different devices. I got my iPad, my phone, and my laptop. and my partner's phone, but I'm glad to see it works with so many people connected as well. So I'll switch now to the code that I've done for this, basically, just to show you how I create it in Firebase. Okay, we'll start with, all right, my Firebase file. So this is just the app that you've just seen. This section up the top here, initializing Firebase configuration, basically has all your connections to your Firebase. And as soon as you want to start using Firebase, you need that little chunk of code at the top to initialize the app, basically, with the configuration. Then to get access to the Firestore, I've just got a function, a self-calling function, which gets the Firestore from firebase.firestore, and I've added these settings. I didn't need to do that originally, but I tried it and a little error came up and told me that I had to handle timestamps in snapshots correctly, so I've added that. I'm still not 100% sure why Google needed to add that, but I'm sure there's a very good reason. And these are just the Firebase methods. So basically, when you go to the website on your phone, I'm logging you in as an anonymous user. So then I've got access to some kind of authorization and a user ID that I can use for whatever I want to. So you can see I've just login user, sign in anonymously. You can get the username. So here I've got the user. You can actually get the user ID straight by going firebase.auth.currentuser. But if you run that to get the user and then you use the user in another function, the next function might be called before it returns the current user, basically, because it's asynchronous. So they recommend that you use this on auth state changed and then pass the user. So that'll make sure it's got access to the user before you use it in whatever function you want. Then I've got the update text in Firebase. So every time you type into the input box, I've just used it as a controlled component in React. And I've passed the input to update text in Firebase. And also just the color. I just gave you a random color in React, so I passed that to the database as well. Call on auth state changed again to make sure I've got the user. And so then I send the details to the document, which has your user ID, and I've just set the text and the color. Then the snapshot, I've just put it in component did mount, so it calls when the component first mounts. I've got the collection user text, and then I've just set the state with the updated text. And I think that is just about a few other things. And that's the Firebase example. There's just a few resources, basically where I've got information, where I've got quotes, where I've used pictures as well. And I've put the article in here, why you should never use Firebase Realtime Database. It is an interesting article if you're kind of seriously considering building something big with Firebase. But what's worth pointing out is they refer to the Realtime Database quite harshly. A lot of the problems I had with the Realtime Database have been addressed with the Firebase Firestore. Yep. Thank you.